Okay, for our circuit unit, we're going to be using an online simulation for a lot of this information. And you're going to go to this website right here. So it's phet.colorado.edu. You can also just search up Circuit Construction Kit, PHET. I guarantee it'll be one of the first ones to pop up. The one thing I would want to recommend is that you make sure that you do the Circuit Construction Kit DC only, and make sure it has the HTML5 icon here. Now, if you're doing this on a Chromebook, this is the only one that will run. I will say this, if you do have a PC and you'd like to go a little bit deeper into these topics, then I do recommend that you do the Circuit Construction Kit AC and DC. You get to work with capacitors and do a few more tricks. But this is the one that's going to work for your Chromebook, the one with the HTML5. So all we're going to do is we're going to hit play here, and it's going to open up the simulation, and then we can work with it here. You do not need to do the introduction. It'll kind of walk you through a few things, but I just jump into lab. And all I'm going to do here is you're going to do some experiments. You're going to have some worksheets that are going to have you build various things. And all I'm going to do here is I'm just going to kind of give you a general overview of how this works. It's a drag and drop system. So if I want to bring a battery in, I just grab it and I throw the battery in. If I want to have a light bulb, I use a light bulb. A lot of the problems we're going to work with talk about resistors. A resistor acts just like a battery. I'm an idiot. The resistor acts just like a light bulb. Apparently my light bulb's not on today. The difference is that the resistor does not glow. Okay, it gives off heat, it gets hot. It's just like a light bulb. The only difference is it doesn't give off any light, but it serves the exact same purposes in all of our equations and setups and things like that. So if something says, hey, put a resistor in, you can put a resistor in, that's fine, but you could also put a light bulb. In fact, I recommend you use a light bulb instead, because you kind of then get to see it light up, you get to see if it's brighter or dimmer, things like that. But it is an alternate option. If you do bring something onto the screen you don't want anymore, you can just bring it back over here, or I think you can, yep, if you just click on it again, it'll become yellow and you can just throw it in the trash. Now, one thing you'll also notice is that you can change the resistance of a resistor. All right, so you have this, it'll go up by increments of 5. Nope, you can't just double click. So you can go increments of 0.5s and go from there. If I click on this, I can also change the resistance of my light bulbs, because again, a light bulb acts virtually identical to a resistor. I can also change the voltage of my battery. I can also flip the direction of my battery. This will be asked of you in several of the examples to say, hey, flip the battery. Well, in this, you just got to click a button instead of having to assemble it and reassemble it. You can also use other things like switches. But these are the main components that we're going to be using here, is light bulbs and batteries. And then you just bring a wire in. It's going to show you where you have to make connections, and you can stretch them. And so just to make things pretty, I usually bring a couple wires in because I like to be able to see where stuff's going. Speaking of seeing where stuff's going, you'll see that once you connect a full circuit, you're going to actually get to see how the electrons are moving through the circuit. This is going to be very important because you're going to be asked questions about flow rate, brightness of bulbs and things like that. So you can see that these lights, right, or these rays of light represent how bright it is. If it were to get brighter, which I'm just going to make it, see, oh, that's brighter, okay. So you can kind of gauge what's going on. I guess I shouldn't have turned it off. There we go, I can still move it. And so you can see the electrons flowing through. Now over here it says show the current. Right now we're viewing the electrons. And one thing that we did talk about is that conventional current is the opposite direction of electron flow. And so you can see that this is basically the way that the conventional current would be going, the way a positive charge would be moving instead of a negative. But you can see that as well. I like to leave as electrons because I like to think of it as a conceptual understanding. You can show values, which I do recommend, because when you do the experiments, you'll be asked to set them at specific values often, and if you set them at the wrong values, then you're data is not going to look correct. It's going to be more difficult to understand the information. So you just want to show those values to make sure you're on the right track. The most common thing that we're going to be using here is an ammeter. Now, an actual ammeter, I got to break that up, has to be put inside of the circuit like this, so the electrons actually flow through it. But since you're not actually building a circuit, we're just asking you to analyze some stuff about it. You can use what's called the non-contact ammeter. And so it will just use this magical device and it will tell you what the current is in the wires, okay, or even the battery. Okay, so you can just put the crosshairs over where you'd like to gather information and it will gather the information for you. For those of you who are experiencing our wonderful lockdown procedures due to the wonderful virus sweeping our nation, we are going to be doing a lot of experiments that are usually things that we do that are hands-on, and they have light bulbs and other equipment, and you guys are going to be using this instead of that. All right, so you become very familiar with this, and this non-contact ammeter is going to be very helpful. All right, so this is just the general setup, so when you're asked to use it, you can feel more comfortable using it. As always, have fun with science.